Hey everyone, thank you so much for joining us today. My name is Charlie Day. I'm going to go ahead and give you a quick introduction to DesignSafe, mention some of the features and our overall goal to this project. And I want to introduce some of the concepts of sharing your data. And then we'll go ahead and hand this over to Carl. Carl's going to be giving us a good tour of LS-Dyna and how LS-Dyna integrates with DesignSafe. Glad you guys can make it today. Let me know if you have any issues, if you can hear me okay. All right, so once again, welcome to DesignSafe. My name is Charlie Day. I'm the director here at TAC. I'm the training professional development. I'm also the training lead for DesignSafe. So if you have any questions or any needs or any webinars that you'd like to present, feel free to let me know. My email is charlie@tac.utexas.edu, and we can see if we can get something together for you. So let me give you an overall vision of what DesignSafe's about. So DesignSafe is a cyber infrastructure. It sits on the cloud. We use a lot of cloud-based tools to support analysis, visualization, and integration of very diverse data types. What the big picture is we want to be able to allow you to bring your data into DesignSafe, and then using these cloud tools to find what that story is that is embedded inside your data set. Our main goal is supporting the end-to-end research workflow and the full research lifecycle of your science. How that collaboration works. You want to set up a collaboration point. You collaborate with other researchers. You share your data with other researchers. Other researchers take your data set and they analyze it and grow it into something brand new with new publications and new published data sets that all are tied back to DesignSafe. And overall, we're trying to enhance, amplify, and link all the capabilities of all the different NHERI components. So the way DesignSafe is split up is we have at the heart of DesignSafe is the data depot. All of our different blocks integrate with data depot. The data depot is the heart of it. That's what holds your data. It looks and feels kind of like a file system. But from there, you can do all of your data analysis, all of the visualization that connects to it. And of course, you can curate and publish your data as well. You can get a DOI, you can cite the data directly into your research paper and and the link will take you directly to DesignSafe's data depot. Our philosophy with the data is we want users to easily store and share their data sets, their documents, everything that has to do with how your data came to being, you'll be able to store and publish. It's a flexible data model. The idea is we wanted you to be able to, we didn't want to tell you how to do your research. We wanted you to develop your data set in whatever model is most comfortable to you, and then be able to bring that model into DesignSafe. And then there's a couple things that we need to do to curate that data. That is, essentially, how do you get other people to look at your data set and understand what it's about? So what we've done is we've created some categories and some of these user-defined categories that basically say what the model configuration is, how the sensors are set up, what the event is that you're analyzing, what type of analysis you're doing, and how the reporting is set up. And we actually have a data curator on site at TAC, and she actually does do office hours from Tuesdays and Thursdays. Dr. Maria Esteva. She's great to work with, and what she will do is she will help you get your data into a format that is easily understandable and can easily be published. So our creation, data creation and publication, basically what we do is we help you define a category tree, all right? And then we assign those categories to different files that are sitting inside of your data set. And then once you have the different categories set up, you essentially can publish your project and publish your files. So the entire setting, once again, is you take your data model, whether it's experimental, simulation, or other, or a hybrid, or reconnaissance work. You take all that information together, you build a category tree, you assign those categories to the different files in your data sets, and then you publish it. And once again, if you ever need any help publishing or have any questions about the data creation process, feel free to sit down with Maria. She is fantastic to work with. So getting your data to DesignSafe, there's a couple different routes you can go. You can upload directly to Jupyter or directly to the data depot. There, if you have a small number of files, say under 25 files, and they're about 100 megabytes each. Or if you'd like to have a bigger data set and they're sitting on your system, you can actually use Box.com or Dropbox or Google Drive. You can sync your folders from your laptop, from your personal local machine to these Dropbox folders, then go to DesignSafe and copy them from one of the cloud storage systems and move them into DesignSafe. If you have a larger data set, meaning over, say, 25 files and greater than 100 megabytes, we actually suggest using Globus. There have been previous tutorials on how to set Globus up. It's kind of there's a bunch of little walkthroughs you have to do that, and we take you hand by hand on how to get your data and Globus set up. So if you hit our document or our training archive, we have that those training videos there for you. But the idea is we want you to make your data count. Hidden inside of your data is a story, and part of what DesignSafe and part of what TAC is all about is trying to help you figure out what that story is. So that is what our end goal is. We want you to help you formally publish your data sets. So it's no longer just formally publishing your articles. You can now formally publish your data set. We can give it a permanent home so that a DOI can link back to the data set. And then, of course, you can link these data sets directly into your CV and we can actually keep track of how many people have cited your data. So we want DesignSafe to be that depot where you're going to be uploading your data to and then doing your analysis work on. So there's a lot of tools involved in this. One of the tools we have is LS-Dyna, right? So LS-Dyna is a general purpose finite element programming, which is capable of simulating complex real world problems, right? It's used in almost every facet of engineering, and we actually have that sitting here on DesignSafe. Carl Bernier, who's a doctoral candidate at the Department of Civil and Environmental Engineering at Rice University, he's going to be taking you guys through a tutorial on using LS-Dyna. His background is he's been assessing the vulnerability of above ground storage tanks. This is actually a really, really cool project. We had some students come here a couple years ago and help Carl mentor these students in building some of these models. More specifically, his research involved developing new numerical models to predict the structural behavior of these above ground storage tanks. He has authored a total of 15 articles, and so he is well renowned in this area. Received his bachelor's and master's in civil engineering from University of Sherbrooke in Canada. So without any further ado, I'd like to introduce Carl, and Carl will give you guys an awesome tutorial on using LS-Dyna. So Carl, thank you very much for joining us today. I'm going to go ahead and stop my share and hand it over to you.
Great, thank you.
So I'm.
All right, so I'll share my own screen.
Hey Carl, I'm not sure if your mic's on or not.
Can you hear me? Or can you hear me now?
Yes, I can hear you.
Okay. Right. All right.
Still can't hear you. I'm sorry.
Okay. Yeah, I think it was the volume of my microphone was very low. Okay, I'll share my screen. I'll move to the presentation. All right, so good afternoon, everyone. As Charlie said, I'm going to show you how we can use LS-Dyna on the DesignSafe.
Yep, you're all set.
Yep. And before starting, I just want to clarify that this webinar is not how we can build model, it's how we can launch job on DesignSafe. So I'm going to show you some example, but I'm not going to show you the details on how I build these model. It's really how we can just use DesignSafe and launch these jobs. So I assume that you already have some basic knowledge regarding LS-Dyna in this presentation. So a small introduction about LS-Dyna. As Charlie said, it's a general purpose multi-physics simulation finite element software package. So it was developed in the 70s by John Alquist at the Lawrence Livermore National Laboratory. It was initially called Dyna 3D, and it was initially developed to simulate the effect of nuclear blast. And then in the subsequent year, they developed it to add contact element and different type of other element to model something else than just nuclear blast. In 1988, John Alquist retired from the Lawrence Livermore National Lab and started his own company where he decided to commercialize Dyna 3D. And he also changed the name for LS-Dyna. And since that time, it's been commercialized by LSTC, and they've made a lot of improvement compared to the original version. So if you want more details about LS-Dyna, you can just click on this link. I'll ask Charlie to make this presentation available after the webinar, because I think there's a lot of insight and interesting thing in it. So what can we do with LS-Dyna? First, we can do 2D and 3D analysis. We can do nonlinear dynamic. We can do both implicit and explicit time integration. We can also do, obviously, static and quasi-static analysis. Thermal and electromagnetic. We can also do CFD, so computational fluid dynamic. There's an incompressible and a compressible solver in LS-Dyna. We can also do fluid structure interaction. Beyond structural and fluid, we can also do geotechnical problem. So there's some model to do solid structure interaction. I'm going to show you an example of geotechnical today. There's also a contact algorithm, so for impact analysis or blast analysis. As I said, there's a large library of elements, and there's a lot more to LS-Dyna that I will probably not show or that most people will not use in their life. So again, you can go on their website to see the full list of what you can actually do with LS-Dyna. So what is available on DesignSafe right now? There's two things that are available, LS-Prepost and LS-Dyna. So LS-Prepost is a preprocessor and a post-processor. So it's basically used to build your model, to mesh your model, and then to visualize your result after you actually run LS-Dyna. And then LS-Dyna is the actual solver. So it's the one who's going to solve your finite element problem. So we're going to switch to the workspace to show you how you can access LS-Dyna. If you go in the workspace and you log with your account, you can go in the research workbench workspace. Then it's load. Then in simulation, you will have LS-Dyna here. So if you click here, you have a scroll down menu here, and you have two options. So you have LS-Dyna and LS-Prepost. LS-Prepost is free, so you can use it without any issue on DesignSafe. So you can directly put your input. However, with LS-Dyna, you need to come with a license. So we do not allow you to use LS-Dyna if you don't already have an existing educational license. So to be able to use LS-Dyna, you need to make a request. So you need to buy a license from LSTC, and then you need to ask DesignSafe team to activate your license on DesignSafe. So basically, once you bought your license with LSTC, you can just click on this button here. It will bring you to the software license page. Mine is already active, but if it was inactive, there will be a link here where you can send a support ticket and ask for your license to be activated. So basically, the DesignSafe team will make sure that you actually have a real license, and then you will be able to use LS-Dyna on DesignSafe. So we'll go back to the workspace. Once your license is activated, LS-Dyna will appear in the My App here. So if you click on My App, now I have LS-Dyna. And now if I click here, we can see that I can use it. Then there's no more the message on how I can activate LS-Dyna. So we're going to go back here. Okay, this is what I just said. Okay. So today I'm going to present three different examples to show what we can do with LS-Dyna on DesignSafe. So the first example, I'm going to show you to launch a single job via the web portal. So it's going to be a CFD analysis. The second example will be to launch a batch of jobs in parallel on the DesignSafe portal. So in this case, it's going to be a structural analysis example. And the last example would be to launch a batch of jobs using the command line interface on Stampede. And in this case, I'm going to use a geotechnical example. So these three examples will show you what we can do with LS-Dyna and how we can use DesignSafe to basically launch LS-Dyna and benefit from the high performance computing at UT Austin for LS-Dyna. So the first example, it's how to launch a single job via the DesignSafe web portal. So I'm going to show you a model of the directional wave basin at Oregon State University. So we had a cylinder in the basin, and we subjected to solitary wave. So we're going to just replicate the experiment in LS-Dyna. So we have an overview of the model here. So we have the cylinder, the wave maker, and the beach here. So I'm just going to walk you through the step on how we can launch that example through the web portal. So the first step is to go in the data depot and make sure that you upload your job file. So you can create a folder. In my case here, it's LS-Dyna. It's called case 1. And I have my K file. So the LS-Dyna files are always .k. In this case, I have 4 different files. Most models will be built only in one file, but I like to have different files for different portions of my model. So this one is the main one. So it defines the control and the parameter of the simulation. This one is the mesh of the wave basin. This one is the mesh of the wave maker. And this one is the motion of the wave maker. So if we open that file here, so this is the main file, the main LS-Dyna file. So if we open it, we're going to see at the end that I have a keyword include to call the other file that I put in the folder. But as I said, you can put everything in a single K file also if you prefer. But my preference is to work with different. So once you have uploaded everything in the data depot, we're going to use LS-Prepost to visualize the model. So we're going to go in the workspace, my app, LS-Dyna, LS-Prepost. So now we're going to launch LS-Prepost on the DesignSafe web portal. The first thing is to select the working directory. So where are my LS-Dyna input file? So they are in LS-Dyna here, and I want case 1 here. Now they will ask for the desktop resolution, the time that you want to run it. Usually LS-Prepost should not take that much time. It's just to visualize the model and make some small change. So we'll ask for 2 hours. We'll put a test, CFD simple. You can select the output location if you want. In my case, I just keep it to the standard one, which is the archive folder. Then you can select the number of node and processor that you want to launch LS-Prepost. Technically, to launch LS-Prepost, we don't need that many cores, so we'll reduce that to 8. And then you'll click on run. It will start LS-Prepost. I will not actually run it because it takes some time to start, but I already started it before the webinar. So basically, after you click on run, you will get this kind of tab here that will open, and it's a virtual computer. And on this virtual computer, you have LS-Prepost, where you can modify the model. So here we see the wave basin. That's what I wanted. Okay. Sorry for that. Okay. F2. Anyhow, I will try to debug it later. So there, when you run LS-Prepost, there's a small glitch right now with the app. So if you go over these button here, the screen will turn black, but it's not a big deal. If you click anywhere else, the screen will get back to normal. So with LS-Prepost, you can visualize the model. Okay, I think it's my keyboard who's giving me some issue. Yeah, so we have the model here that we can visualize. And if you want to make some modification to it, and we can also see the mesh of the model and everything. So that's probably the second step, just to visualize your model using the LS-Prepost via DesignSafe. Once you visualize your model and you made sure that everything was working fine, we can go back to the workspace. Now in the workspace, I will request LS-Dyna. I will select again the directory where my input files are. So case 1. Here is the name of the file that I want to run. So it will be a K file. In this case, if we go back to the data depot and we go back to where I put all my file, the file was osu-basin.k. So this is what we're going to input here. Then we're going to select the runtime. This model is quite complicated. There's more than 1 million elements, so it takes a while to run. So we're going to ask for 48 hours. We're going to put a name, which is called CFD. The output, again, we can leave it as we want. And then here, the last step is to select the number of node and the number of processor per node to launch the job. So there's no really magic trick on how to define the number of processor and the number of node. It's mainly trial and error. So you might want to start with very few processor and start with more processor to figure out the magic number on how you might want to use. There's some rule of thumb that you can find in the documentation that say that around 10,000 elements per CPU might be a good element. More CPU than that might not be that beneficial for your model. So in this case, we're going to select 2 node and 48 processor per node, which, okay. Technically, there should be 68 processor per node, but here it only allows me to select 16. So I think that's a small glitch again. So I'll select 8 with 16. And then we're going to click on run. It will submit the job. And now if you go in the job status here, the bar, you will see your job that has been sent. It is now pending, and then you can update to see what is the status of your job. At one point, it will turn to run, and then it will turn to finish, as we have here. So I already ran this job in the past week, so I can show you the output right now. So once it is complete, so once you have the finish message here, you can basically go back to the data depot. The output, unless you selected your own directory, it will be in archive here. So you can go there and job. And if you go the date you actually launch the job, you will find it. So you have here CFD, which is the one that we just launched. Obviously, there's nothing in that folder because the job has not launched yet. It's still pending. But I did it last week, so we have the result in the past. And here, basically, DesignSafe will put all the output of your LS-Dyna simulation, and then you can transfer them to your computer. So how to transfer them, I think Charlie kind of gave an overview. You can whether send them to Dropbox or Google Drive, or you can use Globus to send them to your computer. In this case, it's probably a good option because these files are pretty heavy. There's probably around 1 or 2 gig of memory. So you might want to look into Globus to move your file back to your computer. Again, we can also use LS-Prepost to visualize the output. So let's say you don't want to do it on your personal computer and you want to do it on DesignSafe. You can go back here, use LS-Prepost. You will input the same thing. However, the working directory will be in archive. It will be the output directory, which is this one here. And then the rest will be the same, and you will be able again to come see your model. I wanted to show you the result of the model, but it doesn't seem to be working as I wanted it to work. If you give me 30 seconds, I can just try to figure out why my keypad is not responding properly. Okay, anyhow, we won't be able to visualize the result for this one. My keyboard doesn't seem to be cooperative today. So. Anyhow, I have a problem with my keypad on my laptop, so it doesn't seem to be willing to let me show you the result. But technically, you should be able to see the fluid and then see the wave. But as I said, it's not really working right now. But that's not a big issue. So overall, that gives you an overview of the different steps on how you can launch a single simulation via DesignSafe. So you have the different instruction in the PowerPoint here. Then, as I said, you can transfer the output back via Globus, or you can use LS-Prepost to visualize the result. But again, it's not working well for me right now, so we'll skip that step. So now we're going to move to the second example. We're going to launch a job on DesignSafe. So this is often useful if you have more than one simulation. So let's say you have 10 different models that you want to launch. You can launch the 10 in parallel. So basically you will have the output of your 10 simulation in the data depot. So I'm going to show you an example based on my research. So basically a storage tank subject to waterborne debris. So we want to launch 5 jobs where the debris impact conditions are different. So basically the velocity of the debris and the orientation of the debris are different for each simulation. So we have an overview of the model here. So we have the storage tank and we have a shipping container, and we're going to launch 5 jobs where we're going to simulate debris impact. So the procedure to do that is very similar to the previous case, except that there's a small difference in the input file. So I'm going to show you the model. So here is the model in the LS-Prepost. So again, you can launch LS-Prepost using the same thing. There's again the glitch I was talking about. And then you can play with the model in LS-Prepost and make some small change. How can we launch now 5 times this model with different debris impact condition? So if you go in my app, LS-Dyna, there should be a third app that is called LS-Dyna_Dyna. I guess that at one point they will merge the two together, but this one was still in development until recently. So that's why it's a separate app. If you click here, this app will allow you to launch multiple jobs in parallel. So again, we have to do the same thing. We're first going to select the working directory. So we're going to go back here, LS-Dyna, and select this one. In this directory, you should have the 5 different input files. So in my case, I wanted to do 5 simulations in parallel. So I should have the 5 input files in the same folder. So as we see here, we have tank 1, 2, 3, 4, 5. And then here we have the dependency. So this is basically the storage tank. This is the shipping container. And this is the load acting on the storage tank, just for the information. And we see we have 5 times the same file. They're numbered here to make sure that we don't overwrite them. So this is basically the directory that we're going to select. You have to make sure that all your files are in the same directory. Then we're going to select the number of processor per job. So this is basically the number of processor for each job. So if I have 5 jobs and I want 4 processor per job, I will use a total of 20 processor. Then the LS-Dyna input, this is the main difference between how we can launch one job and how we can launch multiple jobs. So here we're going to, instead of inputting a K file, we're going to input a text file, which is called myjob.txt. And if we go back in the data depot and we look at that file, so that file should be in the same folder as the LS-Dyna input file. If we click on it, we'll see that that file gives basically lists the 5 different input files that we want to launch. So this will tell DesignSafe that I want to launch these 5 simulations with 4 CPU each, and then it will give me the output. There's also another small difference for people who are familiar with LS-Dyna. Usually the output all have the same name, but you can kind of solve this issue by adding a small command in your K file. So if you open your K file and you save it, just open it. So here you should use, instead of just, normally you will just use keyword, but if you use keyword _ job ID, then it will make sure that the input file will not override each other. So it will put a 1, a 2, or 3, or a 4, 5 in front of your input file, so that will make sure that you don't override your result. Well, when we look at the output from the simulation, we will probably understand it a little bit better. So now we're going to go back to the workspace. So I selected my job.text. So again, this has a list of the 5 different jobs I want to run. We're going to select the job runtime. I'm going to ask for 4 hours, and we're going to call it debris impact. And the output, you can leave it as the default location. Then you have to select the number of node and the number of processor. So when you select the number of node and the number of processor, you need to make sure that you're consistent with what you're asking here. So if you have 5 jobs and you're requesting 4 processor per job, you need to make sure that here you're asking at least 20 processor, so that the number of node times the number of processor per node is at least 20. So here I'm going to change it for 20. So if I had 100 job with 4 processor per job, I should make sure that this time this will give me 400. And here you have the details. So for each node, you have 64 CPU. So this is why it was strange in the other app that it was limiting me to 16. So this can help you if you know that you need 400 CPU. You can just divide by 64, figure out the number of nodes, and then inputting the right number of processor. So again, we're going to click on run. It's going to start the job. And the job should appear here. So we have debris impact that is pending, and it will move to running at one point. So I already ran it this morning, so we can go see the output right now. So once the job is done, you can go to the data depot. Again, you'll go in archive, job. I've launched that job this morning, so it will be in the May 13. It's going to be the one that I launched at around noon. So here I have the output of my 5 different jobs. As I told you, when I use the keyword job ID command, it will put a 1 in front of the output file. So these files here, I know that they are associated with my first job. These one here are associated with my second job, third job, and until the 5th job. So again, you can use Globus to transfer that to your computer, or you can use directly LS-Prepost to visualize the result on DesignSafe. So again, this is what I did here. We should be able to see it this time. If we go to File, we can go Open, D3 plot. We can open just the first one. Oh, it was already open, sorry for that. And that glitch is a little bit annoying, but hopefully it will get fixed at one point. So now we have our model, and we can look at the debris impact, so we can just visualize it and see how the shipping container will move and how it will rebound from the storage tank. So again, I could do it for each of the 5 different simulations that I ran. And then you can extract everything you want back to your computer and work with it. So maybe one notice regarding the batch job. So there's a maximum number of jobs that you can launch. You cannot launch like 1,000 jobs and let it run. So they allow you to use 12 nodes with 64 core. So that's the limit. So if you do 12 times 64, that will give you the number, the maximum number of core you can use. And then if you divide by the number of core you want to use by job, you can figure out how many jobs you can launch at the same. So now we're going to move to the third example, which is launching, again, a batch of jobs, but using the command line interface. So what is the advantage of using the command line interface? There's mainly one advantage, that we have more flexibility when we launch a job than the web portal. So let's say we have some MATLAB or Python code to pre-process or post-process or LS-Dyna file. We can launch them before we actually launch a LS-Dyna job, or we can post-process them using a Python code after the job is actually done. So this, using the command line interface, allows a little bit more flexibility. However, it's a little bit more cumbersome than the web portal, so there's a little bit more step to get there. So the first you will, to use a command line interface, you cannot just use a web interface, so you will need a SCP client to transfer the file on Stampede and take the file from Stampede. And then you will also need a SSH client to actually do the command line. So in my case, for the SCP, I use WinSCP. So these two are kind of mixed up here. And then for the SSH, I use PuTTY. So basically the SCP is the one here. So it's WinSCP. So you will ask to connect to stampede2.tag.utexas.edu. Your username and your password should be the same one that you use for DesignSafe. So there's nothing different. So then you can just click on login. They will ask you for your password, which is your DesignSafe password. And then they will also text you a code to be able to access the command line interface. And now that you're here, we can move to the example. So the example that I will show to illustrate the command line interface is the slope stability analysis under 105 different earthquakes. So we're going to have 105 simulation with different ground motion. Each simulation will have a different simulation. The example was provided by Len Ratch and Young-Kyu Cho, which is a graduate student, I think. And basically, the objective of the simulation is to do a slope analysis and figure out where the maximum strain and maximum shear strain are within the slope. So the first step is to transfer these 105 files on Stampede. So usually, when you will open the SCP client, you will be sent to your working directory, which in my case is Carl46. And then I can create a subdirectory, and I can just transfer the 105 simulation files that I want to run. After I've transferred these files, we have to generate a Slurm script. So most people who have worked with high performance computing probably know what a Slurm file is. So in this case, it is the s.sh file here. So if I open it, we have the command that we send to the Stampede2, and we also have the model that we load, how to access LS-Dyna, and the job that we actually want to run. So the first section here is the setup parameter. So basically, the job name, the number of node, and the number of processor that we want to use. So in this case, we have 105 jobs, and we want 34 core per job. So we approximately need 53 nodes and a total of 3,600 core. Then this is the time that we request to launch a job. This is your email address to receive notification. And this is your account. So it should be your DesignSafe account. In this case, it's DesignSafe-Badget, which is my PI on DesignSafe. Then this step here is to launch some module that we need to run LS-Dyna. And here is we get access to the LS-Dyna license. So again, if you activated your license on DesignSafe, you just need to copy this here and you should be able to run LS-Dyna using the command line interface. Then you change your directory to put where your input files are. So here I am in the same folder where I uploaded everything. And finally, these two command line here are to actually launch my 105 job. So the first one is we're going to generate a Python script that will write files with the, so if we press open it, my parallel line.py. So this Python script will basically generate a file called my parallel line. And in this file, I will have the list of each of my jobs. So a little bit like the text file I showed you on the DesignSafe web portal, I will have a list of 100 of my 100 job, and then I will be able to send that to the cluster. So here, instead of listing it one by one, we use Python to generate the list for us. And then if we go back here, we see that we have another Python file that we're going to use. So in this case, it is this one here. So this Python file basically use PI launcher, which is a Python interpreter to launch a simulation on a supercomputer. So basically, we're going to use this command. We're going to tell him that the job names are in the file that I just generated before. I'm going to show you what the file looks like. So yeah, here, so we have, it will generate a my parallel line file with all the input in this format here. And then we can just use this second code to use PI launcher to launch our 105 simulation. So if we go back here, so yeah, so here we have the list of our 105 job that we want to run. Then we have the number of core per job. So here, as I said, it's 34. And again, that number needs to be consistent with what you ask here. So here we have 105 times 34. So we need to make sure that this here is higher than 105 times 34. Now, after you've created these two files here and the Slurm file, you can access the SSH client. So in most SCP software, you will have a small icon or a small button to click. It will open PuTTY, where you can then access the command line interface. So it will again ask you your password. And it will send you a code that you have to input again. Okay, so now that you are, after you open the PuTTY or the SSH client, you're basically in the command line interface. So you should see your account, so DesignSafe budget, the number of computing units that are still available to you, and the expiration date of everything you have. And then from there, you can actually launch the Slurm file. So again, people who are familiar with HPC computing shouldn't be that surprised of what I'm going to do. So first, you're going to change your directory. So I'm going to change directory where all my 105 input files are. So it's basically CD my directory. And then I'm going to use sbatch and then the name of my Slurm file. So my Slurm file was EQ motion parallel job.sh. So this is the one where I call my Python script. So this is the one I will launch. Then it will make some verification, make sure everything is okay, and then it will submit the job. And then you can see the status of your job using SQ-U, your username. So this will give you, okay, your job is on the normal partition. This is your ID. This is your user. This is the status. This means that the job is pending. If the job was running, it will be R. And this is the number of nodes that you requested. And once all your simulation are run, you will have all the output in that folder here. So I already ran it a little bit last week. I have a second folder here where I have all the different output of my 105 simulation. So again, it's a little bit the same logic as on DesignSafe. We have case 1, then the result. So for each of my different 105 case, I will have the output using that format. So case 48, case 50, till 105. And then you can send everything back to your computer to do some post-processing. So I'll go back here. Yeah, so basically then you can transfer all the output back to your computer and make sure that everything works. So this was the end of the last example. So it will give you a pretty good overview of what we can do with LS-Dyna on DesignSafe. So as I said, we can use the web portal to launch single job, multiple job, or we can use the command line interface if we want more flexibility and we want more control on what we're actually doing. And I think I will send it back to Charlie. And this concludes my part.
Hey, thank you so much, Carl. Hey, thank you very much, Carl, for the demo and walkthrough of LS-Dyna. If you guys have any questions or anything, feel free to contact us at TAC, and we'll be able to answer, or at least find somebody who can answer your questions. You can also contact us through the DesignSafe Slack channel. You should have been invited to the DesignSafe Slack team. You can sign up for that and then be able to answer any questions or ask us any questions there as well. I also want to remind you that next week we have another DesignSafe tutorial coming up. Next week we have OpenSea's Pi and Jupyter Notebooks. Professor Michael Scott from Oregon State University is going to be presenting. OpenSea's Pi is a Python 3 module for OpenSeas, and we have that ready to demo on DesignSafe. Also, if anybody has ever had any questions on any of the previous DesignSafe webinars that we've given, we actually do have a DesignSafe learning training channel on DesignSafe itself. If you go to that URL, designsafe-ci.org/learning center/training, you'll be able to come across all of our past webinars and all of our past webinar material. When this one gets archived and all the material available, this is where we'll link it to. All right, if there aren't any other questions, thank you very much, Carl. I really appreciate you coming, giving us the time, and giving us a walkthrough on LS-Dyna.
You're welcome.
Yes, that was very cool of you.
I'll send you the presentation so you can share it with the webinar. Most of the detail I've talked about are in the PowerPoint presentations. So it would probably be helpful for people.
Yeah, thank you very much, Carl. Also, the samples that you have, if you want to put those together, we can put those in our community notebook. Okay. As well for people to review. So, all right, thank you very much again. And if there aren't any other questions, that will end this webinar, and hopefully we'll see you guys next week. Next week, May 22nd at 1 p.m. Central, we're going to have the OpenSea's Pi and Jupyter Notebooks tutorial. Oh, actually, there's a question coming in now. Yes, go ahead. If you like, you can unmute your mic and ask the question, or you can type that in the chat. Oh, here it is. They'd like to know if there's anyone who can help in obtaining a license for LS-Dyna. So we have the license for LS-Dyna available for DesignSafe users that you can use through DesignSafe. If you are looking for a license for your private use, if you ask us a question on DesignSafe Slack channel, I'm sure somebody can be able to answer that for you. But if you're using it through DesignSafe, we should be able to get you a license.
You still need to have your own license to be able to use via DesignSafe.
Oh, we don't have a DesignSafe license yet.
No, I mean, there's a DesignSafe license, but to be able to use it, you need to prove that you already have a license.
I see, okay.
Yeah.
Thank you for the clarification.
So I think I don't know who asked the question, but if you send a help desk ticket, When you basically click on activate license, you can send a help desk ticket, and they will help you on how to acquire the license and then activate it.
I hope that answers your question. Okay, fantastic. Thank you. Does anyone else have any questions they'd like to ask Carl? All right, if not, we're going to wrap up then. Thank you so much for joining us today. Please join us tomorrow, next week when we have the next Design Safe training event. I really appreciate everyone's time. Thank you again, Carl. I really appreciate your time.
You're welcome.
We'll see everybody next time.